Now let us take a problem on change of variable. Z is given by a function of x comma y, and x is in terms of uv, y is also in terms of uv. Now we need to show that y into dou z by dou u plus x into dou z by dou v is equals to e power 2u into dou z by dou y. Now let us start finding dou z by dou u. So this is equals to derivative of z with respect to first variable x and derivative of x with respect to outside variable u, and derivative of z with respect to second variable y and derivative of y with respect to outside variable u. Now z is not clearly defined here. It will be dou z by dou x. Now x with respect to u, it will be e power u into cos v. Now z with respect to y, z is not clearly mentioned here, so it is dou z by dou y. Y with respect to u, it is e power u into sin v. Now let us start finding dou z by dou v. This is again equals to derivative of z with respect to first variable x and derivative of x with respect to outside variable v. Then derivative of z with respect to second variable and derivative of y with respect to outside variable v. Now it is dou z by dou x into x with respect to v. X with respect to v is e power u into minus sin v. Dou z by dou y into y with respect to v, it is e power u into cos v. Now let us consider left hand side. This is y into dou z by dou u plus x into dou z by dou v. Now this is equals to y value e power u sin v, then dou z by dou u is equals to e power u cos v into dou z by dou x plus the other term is e power u sin v into dou z by dou y. Now x value is e power u cos v into dou z by dou v. It is minus e power u sin v into dou z by dou x plus e power u cos v into dou z by dou y. Now, so some terms will be cancelled here. It is e power 2u sin v cos v dou z by dou x. So this will be cancelled with this term. So we left with e power 2u sin square v plus cos square v whole into dou z by dou y. And this is same as e power 2u into dou z by dou y, and it is the required right hand side. Take another problem on chain rule. So u is given as a function of x, y, z. Okay. For our convenience, let us suppose y minus z as small p and z minus x as small q and x minus y as small r. Then u is equals to u of p, q, r. That is, u is a function of p, q and r. So you can see that p is a function of yz, so you can assume it as function of xyz also. Okay, and q is a function of zx, you can assume it as function of xyz, and similarly r is also taken as function of xyz. Now we need the value of dou u by dou x and also dou u by dou y, dou u by dou z. Let us start finding dou u by dou x. So this is equals to, by chain rule, it is equals to derivative of u with respect to first variable, that is p, and derivative of p with respect to outside variable is x. Then derivative of u with respect to second variable, that is q, and derivative of q with respect to outside variable, that is x. Then derivative of u with respect to third variable is r, and derivative of r with respect to x. Now dou u by dou p into p with respect to x. P with respect to x is 0. Then dou u by dou q into q with respect to x. Q with respect to x is -1. Then dou u by dou r into r with respect to x. R with respect to x is 1. Now let us start finding other derivatives, that is dou u by dou y. So this is also equals to derivative of u with respect to first variable is p, and derivative of p with respect to outside variable y. Then derivative of u with respect to second variable, that is q, and derivative of q with respect to outside variable. Then derivative of u with respect to third variable, that is z with respect to outside variable. Sorry, it is r. Third variable is r. Okay, now it is dou u by dou p into p with respect to y. P with respect to y is 1. And dou u by dou q into q with respect to y, it is 0. Then dou u by dou r into r with respect to y, it is -1. Now let us find the third partial derivative, that is dou u by dou z. This is also equals to u with respect to first variable p, and derivative of p with respect to outside variable, it is z. Then u with respect to second variable, that is q, and q with respect to outside variable z. U with respect to third variable, that is r, r with respect to outside variable z. Now it is dou u by dou p into p with respect to z. P with respect to z is -1. Dou u by dou q into q with respect to z, it is 1. Then dou u by dou r into r with respect to z. R with respect to z is 0. Now let us consider left hand side. It is dou u by dou x. Dou u by dou x is minus dou u by dou q plus dou u by dou r plus dou u by dou y. It is dou u by dou p minus dou u by dou r, and dou u by dou z, it is minus dou u by dou p plus dou u by dou q. On adding, we will get 0, and this is same as required right hand side. Now let us see another problem, that is total derivative of implicit function. Here u is given as x into log of xy, and also given the implicit function x cube plus y cube plus 3xy is equals to 1. So by using this data, we need to find dou u by dou x, du by dx. It can be also called as total derivative. Okay. So the formula for du by dx from chain rule is dou u by dou x plus dou u by dou y, dou u by dou y into dy by dx, where dy by dx is equals to minus gx by gy. Okay. So du by dx is called total derivative. This is the formula for du by dx. It is from total derivative or from chain rule. It is dou u by dou x plus dou u by dou y into dy by dx, where du by dx is given as minus dou g by dou x by dou z by dou y. So here u is given as x into log of xy, and g is given as x cube plus y cube plus 3xy is equals to 1. This is the implicit function. Implicit function means you cannot write y in terms of x or x in terms of y. Okay. Now, let us find dou u by dou x. Both are having x terms. Let us apply derivative of uv. It is x into log of xy derivative. It is 1 by xy, and the internal derivative with respect to x, it is y, plus log of xy into derivative of x is 1 plus dou u by dou y. Here x is constant. Derivative of log of xy is 1 by xy, and derivative of xy with respect to y, it is x. Okay. Now the other one, dy by dx. So this is 1 plus log of xy plus x by y dy by dx. Now we need to find dy by dx. So dy by dx formula is minus gx by gy. Gx and gy are partial derivative, where g is the implicit function. So with respect to x, the derivative is 3x square plus 3y, and with respect to y, the derivative is 3y square plus 3x. So our required answer is du by dx is equals to 1 plus log of xy plus x by y into minus of 3x square plus 3y by 3y square plus 3x. Okay, this is same as 1 plus log of xy minus x into 3x square plus 3y by 3y square plus 3x. Okay, an implicit function is involved here. We need the value of du by dx or total derivative, that is equals to dou u by dou x plus dou u by dou y into dy by dx, where dy by dx can be calculated from the implicit function directly or by using the formula minus dou g by dou x by dou z by dou y. Thank you. See Taylor series expansion for a function in two variables. Taylor series expansion of a function in two variables x and y. It can be also called as expansion of two variable function f of x comma y in powers of x minus a and y minus b. So Taylor series in expansion in f of x comma y, it is also same as expansion of f of x comma y in powers of x minus a and y minus b. Let us see the formula. F of x comma y equals to f of a comma b plus x minus a into fx at a comma b plus y minus b into fy at a comma b, okay, plus 1 by 2 factorial into x minus a whole square fxx at a comma b plus 2 into x minus a into y minus b into fxy at a comma b plus y minus b whole square fyy at a comma b. One more term, 1 by 3 factorial into x minus a whole cube fxxx at a comma b plus 3 into x minus a whole square y minus b into fxxy at a comma b plus 3 into x minus a into y minus b whole square fxyy at a comma b last term, it is y minus b whole cube into f y y y at a comma b, and so on. Okay, this is the formula for Taylor series expansion of f of x comma y, or it is the formula for expansion of f of x comma y in terms of or in powers of x minus a and y minus b. Here f of ab, it can be evaluated by substituting x equals to a and y equals to b in f of x comma y. Then fx is the first order partial derivative, that is dou f by dou x, and evaluate the function at a comma b. Similarly, fy is dou f by dou y. Then fxx is dou square f by dou x square, second order partial derivative. Then fxy is dou square f by dou x dou y. Then fyy is dou square f by dou y square. Now fxxx, it is third order partial derivative, it is dou cube f by dou x cube. Then fxxy, it is dou square f by dou x square y, dou x square dou y, third order. It is fxyy, it is dou cube f by dou x dou y square. And the last one, fyy, it is dou cube f by dou y cube. Okay. Now, by substituting a equals to 0, b equals to 0, you will get another formula, and the formula is known as Maclaurin series for the given function, or expansion of f of x comma y in powers of x comma y. Okay. Now you put x equal to 0, you put a equals to 0 and b equals to 0. The new formula is f of x comma y equals to f of 0 comma 0 x into fx at 0 comma 0 y into fy at 0 comma 0 plus 1 by 2 factorial into x square fxx at 0 comma 0 2 into xy into fxy at 0 comma 0 plus y square into fyy at 0 comma 0 plus 1 by 3 factorial into x cube fxxx at 0 0 3x square y into fxxy at 0 0 3xy square into fxyy at 0 0 plus y cube into fyy at 0 0, and so on. Okay. On writing a equals to 0, b equals to 0, this is the new formula, and this formula is called Maclaurin series expansion of the given function, or expansion of f of x comma y in powers of x comma y. Okay. So this is called Maclaurin's expansion of f of x comma y. The other name is, this is one name, the other name is expansion of f of x comma y in powers of x comma y. The other name is expansion of f of x comma y in powers of x comma y. Okay. So in examination, if he is asking for up to terms of degree 3, you need to evaluate up to this term. If he is asking for terms up to degree 2, you can do the derivatives till second order derivatives. Okay. If he is asking for third order derivative terms, he will consider the whole formula. If he is asking for second order derivative terms, it is enough if you calculate and substitute till second order derivatives. So let us take another problem on Taylor series expansion. So it is given that f of x comma y equals to tan inverse of y by x. So you need to expand this function in powers of x minus 1 and y minus 1. That is same as by using Taylor series expansion. So here a is 1 and b is 1. Now the first term of Taylor series expansion is f of a comma b. So it will be f of 1 comma 1 and it is tan inverse 1 and it is equals to pi by 4. The second term of Taylor series expansion is x minus a into fx at a comma b. Now let us start finding fx. So fx is dou f by dou x. It is derivative of tan inverse of y by x. It is 1 by 1 plus y by x whole square, and internal derivative of y by x with respect to x, it will be minus y by x square. It is minus y by x square plus y square. Now fx at 1 comma 1. Now fx at 1 comma 1 is minus 1 by 2. Now the next term is y minus b into fy at a comma b. Let us start finding fy. Fy is dou f by dou y. It is 1 by 1 plus y by x whole square, and internal derivative is y by x. Internal derivative for y by x with respect to y is 1 by x. It is x by x square plus y square, and fy evaluated at 1 comma 1 is also 1 by 2. Now the next term is 1 by 2 factorial into x minus a whole square fxx at a comma b. Now let us start finding fxx. So fxx is the derivative of fx. This is fx value. Now differentiate this with respect to x. So here minus y is constant. So remaining is 1 by x square plus y square. It is of the form 1 by x. Its derivative is minus 1 by x square, and internal derivative is 2x. So it is 2xy by x square plus y square whole square. Now evaluate this at 1 comma 1. This will be 2 by 2 square, that is 4, and it is also 1 by 2. The next term is 2 into x minus a into y minus b into fxy at a comma b. Now let us start finding fxy. So it is derivative of fy with respect to x. This is fy, derivative of this term with respect to x. So both numerator and denominator having x term, apply u by v formula. So x square plus y square into x derivative 1 minus x into 2x. Now it is y square minus x square by x square plus y square whole square. Now let us evaluate this at 1 comma 1. So this will be 0. The next term is fyy at a comma b into y minus b whole square. Let us start finding fyy. It is derivative of fy with respect to y. This is fy. X is constant. So minus 1 by x square plus y square whole square, and internal derivative 2y. So it is minus 2xy by x square plus y square whole square. Now evaluate this at 1 comma 1. Yy at 1 comma 1, this is equals to minus 2 by 2 square, that is minus 1 by 2. Now substitute all these values in the formula, Taylor series expansion formula. If he is asking for third order derivative terms, so you can start finding fxxx, fxyy, fxxy, fyy. Since it is not mentioned that you need to find till third order derivatives, I have calculated up to second order derivatives, and I am substituting these values in the Taylor series formula. If he is asking for third order derivative formulas, definitely you need to calculate the third order derivatives, but here it is not mentioned about third order derivative terms. So I am stopping at second order derivative terms and substituting these values in the formula. So from Taylor series formula, f of x comma y equals to, the formula is f of a comma b plus x minus a into fx at a comma b plus y minus b into fy at a comma b plus 1 by 2 factorial into x minus a whole square fxx at a comma b plus 2 into x minus a y minus b fxy at a comma b plus y square y minus b whole square fyy at a comma b, and so on. Now substitute. So it is equals to f of a comma b, it is pi by 4. Here a is 1 and b is 1. X minus 1 into fx at a comma b, that is minus 1 by 2, plus y minus b into y minus 1 into y minus b into fy at a comma b, that is 1 by 2, plus 1 by 2 factorial x minus a whole square fxx. fxx value is at a comma b is 1 by 2, plus 2 into x minus a into y minus b into fxy. fxy at a comma b is 0, plus y minus 1 whole square into fyy at a comma b, it is yy at a comma b is minus 1 by 2, and so on. Now continuation of this step. F of x comma y is equals to pi by 4 minus 1 by 2 into x minus 1 plus 1 by 2 into y minus 1 plus 1 by 2 factorial into 1 by 2 into x minus 1 whole square minus 1 by 2 into y minus 1 whole square, and so on. So this is the expansion of f of x comma y by using Taylor series, or this is the expansion of f of x comma y in powers of x minus 1 and y minus 1.